Welcome to product design and development. In this video, we'll focus on the process of concept selection. Just a review of mechanical design process and what we discussed in this course. Again, we don't cover the last phase that's mentioned here. We are on phase 3 of the project. The keyword that we use for it to kind of remember is either design or concept in general. So hopefully we have generated some concepts in previous steps. Now we want to kind of evaluate concept, choose the best concept, and make sure that it's properly documented. So this is where we are in our mechanical design process in general. Again, a repeat slide from previous videos. We are phase 3 here of the project. We are still in the system level design. We have generated the concept already. We are evaluating and selecting feasible concepts. So this is where we are on the conceptual design phase. Once the concepts are selected, and sometimes we do concept testing, which is a topic of next video, then we move on to the detailed design and further developing the design and the concepts. Concept selection is the process of evaluating concepts with respect to customer needs and other criteria compared to relative strength and weaknesses of the concepts and selecting one or more concepts for further investigation. Pretty much narrowing the sets of concepts and alternatives that are we considering. So that process of narrowing is often referred to as conceptual design funnel. The red dots here represent the concepts that we have generated in the concept generation step. Remember, that was a five-step process. That was a topic of previous video. So make sure that you have watched that video before this. So now the goal is to go from these sets of red concepts, however many we have, narrow it down to this one viable concept that we can move on. So this blue border that we see here is that concept selection phase of the project. That's what we are trying to do in this step. The concept selection in its own is a two-step process. It's a two-stage or two-step process and involves concept screening and concept scoring. Each of them is supported by a decision matrix that we will talk about it. Screening is a quick approximate evaluation, and its goal is to produce few viable alternatives. And then the scoring is more careful analysis of relatively few concepts in order to choose one or maybe few and move forward with the further detailed design of the project. This is an iterative process, means you can go back and forth on this and kind of refine your concepts and then move forward and then move back a little bit and so on. There are different ways that the concepts could be selected, result of concept generation. You can have an external decision when concepts are turned over to a customer, to a client, or some other external entity, and they will select the best concepts for you. Product champion is when an influential member of the team, product development team, or the company or a supervisor choose a concept based on some personal preferences or some of other criteria. Intuition is another one, which you just feel good about a certain concept and just move forward with it. You can vote on the concept. Each member of the team can vote for what concepts they prefer, and the most votes will win. You can create a list of pros and cons and compare the two. You can use a linear decision-making model, which is a little bit more engineering and more structured scientific way of pros and cons, when you even put weights for each pros and cons and then tally the weights and tally the scores and how you decide. In a lot of cases, depending on the project, depending on the product, you build few or several prototypes and kind of test the prototypes, and kind of based on the results and test the findings, you move forward with one or few of those prototypes and concepts. In this class and in this video, we'll focus on decision matrices. The team rate each concept against engineering specification and customer needs, and based on the creation of certain criteria. And again, we talked about the screening and scoring steps, and then the best matrix is selected and move forward. The benefit of having a structure method, for an engineering product design course or team, is that it helps maintain objectivity throughout the concept phase, and kind of guide the product development team through this complex process. For this video, the case study or the examples we're going to see is a reusable injection syringe by Novo Nordisk, and known as NovoPen. And the one we're seeing here, some of the concepts and some of the examples are from this NovoPen development case study. The team here, went back to QFD, looked at their engineering specifications, looked at their customer needs, and they wrote down some criteria. Again, these criteria could come from your QFD, or could be some additional customer needs that you have learned throughout this process since you've completed your QFD. Their criteria you can see here, very generic criteria: ease of handling, ease of use, readability, dose metering accuracy, durability, ease of manufacturing, and portability. Their audience and their customer target audience was elderly individuals, so portability, also ease of use and readability was some of the criteria within there. So hopefully the team, with going through this process, this two-step process, we're hoping to answer these questions and be confident that they're selecting the best concept, and again, they're kind of maintaining objectivity throughout this selection process. Results of their concept generation step, as you can see, were concepts like the ones that are presented here. Each concept has a sketch. Each concept has a letter name, concept A through G, and each concept has a name. For example, master cylinder, or lever set, or dial screw. So some way to identify the concepts. Another important point that I want to mention is, at this stage, we want each concept to be presented with the same level of detail as other concepts, and same level of information is provided for each concept. We don't want one concept to be a poor hand sketch versus the other one is a beautiful 3D CAD rendering. Then that kind of eliminates that objectivity, and people will form a biased opinion towards one, or when you see a better sketch or better CAD model, you understand that concept better, versus maybe a poor hand sketch doesn't convey all of that information. So whatever it is, and whatever the concept presentation is, they all need to be kind of the same level of details included with all of them. When we look at each of these concepts, although the sketches are relatively easy, you still have information pointed out with leader lines that kind of tells you what the function or what are some of the parts of each concepts are. So the goal is to select one final concept from this pool of concepts. We mentioned it's a two-stage process. Concept screening is the first step, and then concept scoring. Screening is a quick approximation of approximate evaluation of many concepts that we start with, in this case with 7. You put the result of concept generation steps into it, and the output of it would be a few viable alternatives that you can move on to the concept scoring. So they take the output of screening and use it as an input into scoring. It's a more careful analysis of relatively few concepts. A single, hopefully, concept is selected as a result of this. Or again, depending on the type of project, type of company, timeline, few promising concepts might be selected as a result of scoring and move on to the prototyping and further development phase. But so we'll look at the screening first, and then scoring. Each of them are a 6-step process. You first start by preparing a matrix. And so remember, we have hopefully a 1-page sketch of each concept, as you saw here, all with the same level of details. So all concepts are entered along the top row of the matrix as the column headings here. They mentioned the letter code for them and the name of each concept. The selection criteria listed along the left-hand side of the matrix. Again, these came from QFD, from customer requirements, so from that stage, or they could have been modified throughout the process a little bit further. The next thing is you select a reference. In this case, concept D was selected as a reference. You don't have to select one of your concepts. You can select an industry standard as a reference. You can select a commercially available product, or you can select even an earlier generation of the product as a reference. So this again depends on what did you do in your benchmarking when you were doing QFD. So that affects how your references are selected. So that's preparation of the matrix. That was phase 1, when you kind of fill out the left and top part of the matrix and enter your concept names. Then you start rating the concepts. You give the concepts a relative score. So in each concept, you compare it to a reference in that criteria, and we go row by row, not column by column. What it means is, for ease of handling, we start from here, we compare concept A to D, and we give it a 0. That means it's this, in this criteria, is the same as concept D. Then you move to concept B. Again, concept B is same as concept D in ease of handling. Then you move to concept C. Concept C is worse than our reference in ease of handling, and so on. So you go row by row. It's very important to go row by row and not one concept at a time. Then you move on to the next row, and so on. So again, 0 means same as your concept. Plus means it's better than. And minus means is worse than. So again, it's a quick relative comparison. Once you do that, that's a step 2. Then you start ranking the concept. You add all the pluses, you add all the zeros, and you add all the negatives or minuses, and then you tally them up and you get a net score. And based on the net score that each concept gets, you get a ranking rank to the concepts. After this step, you're not automatically selecting the top ranks. You're looking at it and see, okay, we clearly have a winner or 2. We're going to move forward with those. They are yes. There are some clear losers here that we're not going to select for moving forward with. So you put those aside. But there are some that are in between. And maybe they're a really good concept, but maybe they lack in one aspect of the aspect and criteria that we kind of covered here. Maybe it's a really good concept, but maybe it's not very portable, which was the case in this concept. So that's how they either revise them, like concept G was revised, and then maybe ease of handling was the only negative with this concept. So they're like, what can we do about that one aspect of it? So let's revise it. In concept F and D, so they take the good aspect of concept F, good aspect of concept D, combine them together and move forward with. So we had 1, 2, 3, 4. So 4 concepts were selected as a result here, and 2 of those out of those 4 are newly revised and formed concept. So here's the first one, that was concept G, that as you can see, the ease of handling was one of the negative aspects of that concept. It was too big, too bulky, and they kind of revised it to make it a little bit easier to handle the device. So this was the revised one. They call it G plus or dial screw plus. And then concept F and concept D were combined together. Each of them had some positives, some negatives. So they take positive out of each of them, put them into one concept, and call them concept DF or lever stop. Lever, it was concept lever set and plunge stop. So they come up with lever stop as it's kind of abbreviated name for this. So now with these 4, they move on to concept scoring. Still 6 steps are mentioned here. In these 6 steps, again, you prepare the matrix the same way. You move your concepts as your columns and column headings. The criteria come, selection criteria goes on the left-hand side. The difference in this case is you take each of those criteria from your screening matrix and break them down into further details. So each of these needs to be broken down into details or more detailed criteria when you are trying to evaluate. So the criteria gets broken down a little bit into more detail, but also you're going to add weights to each of these. Again, you go back to your QFD and you remember what each customer what each customer wanted and what was important to who, what versus who section of your QFD. Pay attention that these weights, again, they add up to be 100%. Again, you still have 100 points to spend, and that's to make sure that you give true relative strength to each of these criteria. Again, you still select a reference. In this case, concept A was selected as a reference. Same as before, you can select, other products or industry standard, older version as a reference. In this case, concept 8 was a reference. When it comes to rating the concepts, the rates are a little bit more defined. It's still qualitative rating, much worse, same as, better than, and much better than. So concept A was a reference, so all of the scores are 3 except 2 of them. In those 2 criteria, readability of the setting, concept DF was a reference, and in durability, concept G plus was a reference. This is to show that for each criteria you can have a different reference, and that's another reason that's important to go row by row when you are evaluating and not concept by concept. So again, it's important to go row by row, one row at a time. Once you rate each concept in that evaluation criteria, that's when you move on to the ranking the concept. You use this equation, which is you multiple these 2 score by each other, and that's the score, and then you sum up all of the score all the way down for that concept, and that's the score for that concept. Result of this hopefully is one winner that you can select and move forward with, or it's always a good idea to have a winner and a runner-up in case something happens or you want to modify, revise something. You always have a backup. But in this case, their 3.45 was the winner in this case, and they decided to develop and move forward. And it's interesting to look at, this was the modified, or sorry, the combined D and F concept. So you can see the result of this concept selection wasn't even one of the initial 7 concepts that I started with. So that's important to kind of keep an open mind throughout this process, that you can always revise and you can always review what you have put throughout this process, and that goes back to the being an iterative process. When it comes to reflecting on the process, step 6, we'll get back to this one. I don't have the reflect slide here, but when it comes to reflect is so kind of reflect on the whole process and make sure that there wasn't any other criteria that you missed from your QFD. There wasn't anything else that customer wanted that was kind of left out, and there wasn't any other good concepts in your screening and scoring that you left out because maybe they were kind of poor performance. They had a poor performance in one of the criteria only. So in addition, make sure every member of the team feels comfortable and confident in this selection moving forward. So that concept DF, that was a combination of the 2 concepts mentioned here. This is the picture of the final product that eventually was developed for Novolog or NovoPen insulin injection. I can show you a few tables. These are from your textbook, Product Design and Development textbook by McGraw-Hill, called Ulrich, that give you some idea about some of the criteria. This one is a screening matrix, so you can kind of see they're all plus and minuses, plus minus zeros, and this one has a clear reference. The quick way to find it is that it's all zeros top to bottom, and every concept, it was compared to this one. Again, it's important to go row by row when you're doing your concept selection, 1 row at a time, and then you can see how they summed it up. They gave it a net score and a ranking, so you kind of see what were their top concepts. They have a lot of ones here. So in this case, if a concept is ranked 15 or 7 or 10, they don't have a much chance to move forward with. And then here's a scoring matrix example. This one doesn't have a picked clear reference, but you can kind of see some of the detailed criteria here. You have the weight for each of those. You have the ranking. Also, another difference between this and what we covered here, this one has a little bit more detailed ranking, rating. Sorry, it goes to 10. So it's not just 1 and 5 when it comes to rating. So these are just some inspiration. If you're working on your project, you can look at some of these criteria and get help from these tables. Thank you.